Hello everybody, welcome to the High School Forensics Finals walkthrough. I'm Swat for Sci4, and today we'll be walking through the solutions for the 2013 Storyline Finals. At 9 o'clock a.m. on Finals Day, teams were distributed hard copies of the storyline, leading them to a website, hsfbook.isis.poly.edu. All finalist teams having dealt with this website during the prelims should be aware that the site used Internet Protocol version 6 IPv6 addresses. Knowing that, teams were to use IPv6proxy.net to navigate to the website hsfbook.isis.poly.edu. Once arrived at the website, teams were to find different posts made by various users. Scrolling through these and continuing analysis, teams were to navigate to page 2. On page 2, teams would find an image posted by Mark Rogers. Teams were supposed to download this image and save it for analysis. The file name is doge2.gif. We'll go ahead and come back to this. Scrolling to the bottom of this page, teams would recognize that there are messages that are not immediately legible by humans, such as the last post by Jim Dibner on Julian Jacobs' message board. This message is a Caesar cipher shift 23 and decrypts to "you don't have the nuts." Continuing on, teams would focus to page 3 and notice that there are more messages that are not immediately readable and are encoded. Shifting that, Julian Jacobs posting to Jim Dibner's message board a shift 13, "I'm going to tell on you so hard." And finally, another Caesar shift message, Julian Jacobs to Moshe Wunsch, a question being asked using shift 13, "Our class is going all right." And finally, the last encoded message from Mark Rogers to Jerry Burns' message board is a base 64 encoded message, and it reads, "How are things going at the bank?" Teams were supposed to use various online tools available to decrypt these messages and add them to their report to append to the storyline. Going back to the image posted by Mark Rogers, as you can see, this is a Doge image. Teams had two choices to analyze this image after downloading it. One is to use a terminal of a OS X or Linux shell and use the strings command. As you can see, Doge2 is in this directory, and if I run strings on Doge2, I can analyze the strings in the file, and I get a URL, the form of HSF cdn.isis.poly.edu. It's a download link, and with that, teams would get the next piece of evidence, which is a AVD device, Android virtual device, from which they would continue their analysis. Another method which could be used is a hex editor to recover this information, and teams would simply open up the image and realize that in the hexadecimal, in the ASCII string data, there is a URL there. Next, teams would begin by analyzing the AVD. Here I have the Nexus 7 AVD open, correctly configured in SDK Manager. If you do not know how to do this already, please see my previous tutorial on Android SDK Manager on the modules under Sci4, sci4.isis.poly.edu. There I will explain how to configure and install SDK Manager and how to configure an AVD and ensure the correct packages are available. Assuming teams already know how to do this, we can go ahead and begin AVD analysis and begin by unlocking the device. First, we're going to start with messages and see if there are any on this device. As we can see, there are 4 message threads, one with the owner and Jim Dibner. As you can see, scrolling through, that there is an entire thread. And at the beginning of that thread, we can find a new evidence container, hsfpin.isis.poly.edu. And then there are more details that contribute to the storyline. Teams are supposed to make note of all of this. Going back, continue analyzing the rest of the threads. This thread seems to be with MW. and it has more information for analysis and adding to the report. The next is a thread with Julian Jacobs, and more information after to add to a report. And finally, a thread with Jerry Burns. And this thread is actually more important to the storyline in figuring out who the killer is and gives more information. There's a reference to Twitcher with the owner of the phone saying, but he said something to me on Twitcher and I'd like to know what he knows. I'm surprised you're not more intrigued. And there's also a reference to the phishing scheme from the preliminaries. And there's also a reference to Moshi. All of this information should be analyzed and added to the report for the teams. So now we're going to go ahead and analyze any calls on the device. So clicking the calls icon on the Android OS, we can first see recent calls that have been made. So you can see on November 10th, there were calls made to Jim Dibner, incoming calls and outgoing calls from MW, Jerry Burns. So there's an extensive call history that team should have noted. Now we're going to go ahead and look at the web history, see if there's anything to analyze there. So to summarize, at this point, team should have added the HSF pin link to the reports for future analysis. So going into the web browser, we're going to go and look for history. And click history. And as we can see that there is older history, there's a link to HSF Twitcher, which was also referenced in the text messages. So now we have two sources for evidence, which is HSF Pin and HSF Twitcher. Also scrolling through, there are more references. There's also a link to hsfgit.isis.poly.edu, as well as HSF Book as the website that just referred us here. So there are three new containers which are opened up by the web history: HSF Twitcher, HSF Git, as well as HSF Pin. So we're going to go ahead and continue our analysis of this device and make note of any applications installed. We see that there is a KeyPass droid installed on the device. Just going to go in there, so there's really isn't anything in there. File not found. We're also just going to make a note in our report of all the other applications on the device. To continue analysis, we're going to take a look at the contacts. We see a bunch of contacts here on the device, and now also from the Me contact on the Android OS, we can determine that this phone belongs to Mark Rogers, and we have his email address as well as his phone number. Finally, in order to end the analysis of the AVD device, we're going to go ahead and look at the email, and as we can see, there is a notification that sign-in was not possible. So we're going to go ahead and open the email application and read email using the client. So as we can see, there are various messages from Jerry Burns, Moshi Wunsch, Julian Jacobs, Moshi Wunsch, and messages. We see one interesting one back from the preliminaries from Luke Hunks. We see various messages overall. The newer ones start from November 8th and continue on. These are all things that should be noted for the storyline. As you can see, there's a message between Moshi and Jim Dibner that Mark was copied on. and it's about a one-man army, referring to the Cybernuts. Making note of all of that, that concludes the AVD analysis, and teams should have made note of the SMS information calls, the web history, which leads to 3 new containers, the applications on the device, the contacts, as well as the email for the storyline. The next step is to analyze HSF Git, but we will also go through the HSF pin and HSF Twitcher for circular redundancy. From the AVD, teams should have learned of 3 new containers: HSF pin, HSF Twitcher, which was used in the preliminaries, and HSF Git. We'll begin by analyzing HSF Git, and the URL as found in the AVD is hsfgit.isis.poly.edu. Typing it into our browser, we see that it is an IPv4 address, so there's no need to use a proxy. And on this, we see it's a Git repository using Git prep of different users and their programs. Teams were to go ahead and analyze the repositories and find under danger zone a couple of repositories. The first one being TC password, indicating it's a TrueCrypt password, and also a GPG public key. Also among the repositories are a scrape script, a GoFish script, and a JSON script. The GoFish refers to the prelims phishing scheme from the Cybernuts and should be noted in the storyline. The TC password, I'm going to go ahead and analyze that repo and find a TCPW file, and in that we note the password for the TrueCrypt volume, which we have not at this point discovered. So to go back, we're also going to go ahead to the GPG repo and go ahead and look at the private key. See a private key here. You could also go ahead and actually download this repo to have a copy of the private key. Next, we're going to go ahead and continue to HSF pin and analyze the evidence there. So I'm going to begin by typing it in to my browser, hsfpin.isis.poly.edu. Typing it in, I'm getting a web page not available, so I'm going to use the IPv6 proxy again. So we're going to go ahead and type in hsfpin.isis.poly.edu and use IPv6 proxy to tunnel over. Now we see it's loading a page, HSF Terrest, with a couple of images. And just scrolling the page, we see that the links have been clicked. However, immediately there's one link that sticks out, which is going to use this on my computer. It's a separate URL, and it's from JimDibs7, Jim Dibner from the storyline. So we can go ahead and actually click this link, and it's redirecting us to HSF CDN, which is another download for evidence. Reason we're getting this error here is because it's on a IPv4, it does not have an IPv6 address. So we're just going to copy the URL it leads to and just paste it into our browser. And go ahead and start downloading. So as you can see, that begins downloading a virtual machine, as Jim said, on his computer. So this will be a virtual device. So we're going to go ahead and begin analysis of this virtual machine. After downloading the virtual machine from the computer link, we see that it's the HSF Labs computer, and the user is HSF ISIS. It's a suspended virtual machine, and the previous command run is ifconfig, listing the IP addresses. Finally, we're going to go ahead and begin analysis of this machine. Go ahead and start at the root folder, and from there we see that there is a home directory, and in that home directory it's the current user and his files, among which there are a bunch of GPG files. going to go back to the home and navigate to the lab directory, cd lab, and on which we could find different users of the lab, including Danger Zone, G. Burns, Dibner, Julian Jacobs, Mark Rogers, Moshe Munch, and an OTP.ssl file. Teams are supposed to go ahead and perform analysis on the rest of the folders and see under Danger Zone there's folders attacks under which there are some applications here that are well worth noting, and a couple of PDF files. Also, teams were supposed to realize that there is a reference to the Git HSF repo for a Danger Zone. As you can see, the GPG key is also in this machine, as seen in the GPG folder. Also, as you can see, the TCPW, the TrueCrypt password, is also in the same folder, as this is a mirrored repo of the HSF Git. From here, teams were supposed to continue and analyze the rest of the folders and continue analyzing all the other applications for the other users. Now we have the HSF Lab virtual machine disk mounted in an Ubuntu Linux distribution installation. We have it mounted as a read-only volume for the sake of maintaining all the files as we access them and write to them. Teams were supposed to go ahead and analyze all the folders and make a report of all the containers of all the users mentioned here in the lab folder. We're going to go ahead and focus on M. Rogers, Mark Rogers' username, and under that we see that there are multiple folders with documents, pictures, and random. Teams were supposed to make note of all of this. In there we also see a Barnaby text file, which was a false confession set up by Mark, noting that he would avenge the death of Joel. We also see that there is a myvolume.tc. This was actually a dummy file set up by the team to ensure that the teams playing the challenge would be thrown off into thinking that this is the TrueCrypt volume. The actual TrueCrypt volume teams were supposed to find is Steph's, and we're going to go ahead and mount that using TrueCrypt. So opening TrueCrypt, I'm going to go ahead and select file. Selecting file, we're going to go into our volume. I'm going to go into lab. And then from there, we're going to go into Mark Rogers. We're going to go into Steph's. And it's a 1.4 gigabyte TrueCrypt volume. I'm going to go ahead and mount it. Putting in the password we found earlier from the HSF Git. The password written in LeetSpeak. So now we're going to go ahead and analyze this volume. In the volume, we see a folder called phishing, and we see a fish.csv script opening it up in Ubuntu. This looks like information that was obtained via a phishing scheme. Also, we see multiple JPEG images and a PowerPoint. Among that, we see a file that has subroutines and calls. The important things to note were the applications that are in this TrueCrypt volume include exploitation applications such as AirCrack, Burp Suite for intercepting web traffic, Metasploit, and UPX for unpacking and packing. Another important file to note is a financials.db. Another important file to note, and actually the most important file in this directory, is pw. Opening up this file, you see there is a new password obtained called hackademics. So right now we do not immediately have anything that requires a password. However, we're going to make note of this password in our reports to make sure that if we do encounter something, we can use it down the road. As you can see, we're working in the lab directory doing a list all. We see the other users on the machine as well as a otp.ssl file. Going back to the HSF Git, team should have realized that there was a private key file within there, and SSL uses private keys for decryption. Knowing that, teams were supposed to run OpenSSL, and the command would be OpenSSL SMIME decrypt, taking in otp.ssl, binary, form, in key, private key.pem, out otp.zip. Running this command, teams would receive a zip file, and from there they would continue their investigation. Now that teams have opened the SSL container using the private key.pem file, teams should have received a one-time pad.zip archive, and this zip is password protected. And recollecting back to their TrueCrypt analysis, teams should realize that the password is the zip PW file, and within it is stored the Hackademics string written in Leet. I have that pasted on my clipboard. I'm going to go ahead and enter that to decrypt this zip one-time pad. Within it we see text files, which seem to be encrypted in some way. These text files are actually part of the confession message, determining who the killer is. So in order to properly read this, we're going to use a Python script I wrote here, using the glob method and the XOR strings. We're going to open each file, we're going to read the line inside, and we're going to use an accumulator to XOR all of the files together, or exactly the strings within the files. So we're going to go ahead and open up a terminal window. Go ahead and navigate to the directory. Okay, we're going to just list all the files, make sure we're in the right directory. See that have the correct files. And we're going to go ahead and run the Python script. Before we do that, I'm just going to move the script into the zip directory to make it easier. And run the Python script. And from there we see the confession message signed MR. Therefore, teams would go ahead and deduce that the killer, and therefore the solution to the HSF 2013 finals, killer was Mark Rogers.